Okay, class, in this lesson, I am going to show you how to solve compound inequalities and graph them on the number line. So before we get started, let's define what a compound inequality is. So the definition of a compound inequality is an inequality that is formed by the union or, the word or the intersection, which is represented by the word and, of two simple inequalities. So, for example, you could have x is greater than 2 or x is less than -3. Okay? So if you were to graph this, it would look like this. Here's our -3. Let's say this is 0 and this is 2. Okay? So we're going to graph x is greater than 2. So we're going to have an open circle at 2 and then draw an arrow to the right because all values greater than 2 are valid. And we're going to put an open circle at -3 and draw an arrow to the left representing all values less than -3. Okay, so this is called a union because we see the word or. So this compound inequality states that x is less than -3 or x is greater than 2. Okay, so let's take a look at a second example where there is an intersection. So let's suppose we have this expression. X is greater than 2 and x is less than or equal to 7. This inequality is read as all numbers greater than x and less than or equal to 7. So what this means is that this inequality can be rewritten as such. X is greater than 2 and also less than or equal to 7. This is called an intersection using the word and. And to graph this on the number line, it would look like this. We would have an open circle at 2 because we're not allowing to equal 2. It has to be greater than 2. Okay, we're going to move in this direction, greater than 2. And I'm going to stop there because this is an intersection. So we're going to plot a closed circle on 7. And it's going to be less than 7, less than or equal. So we're going to connect the lines here. Okay, so on a number line, we have represented all numbers greater than 2 and less than or equal to 7. So in this last problem, when you have an intersection or using the word and, there's another term to describe this scenario, and it's called conjunction. In the previous example, there's also a term to represent this scenario, and that word is disjunction. So when you have an inequality that is formed by a union, or with the word or, the term is called disjunction. And then when you have two inequalities that intersect or have the words and, the term is called conjunction. Okay, so now that you understand the terms conjunction and disjunction, let's see what happens when we turn a conjunction into a disjunction, as well as turning a disjunction into a conjunction. Okay? If that was confusing, let me show you via a couple examples. Okay, so let's say we have a conjunction right now where x is less than or equal to 1 and x is also greater than -3. So another way to write this is, and I'm going to move it over here to the right here, x is less than or equal to 1, but it's also greater than -3. Okay, now if we were to graph this on the number line, it would look like this. Closed circle at 1, open circle at -3, and we would connect those 2 points. Okay, so what would happen if this became a disjunction? Okay, so in other words, x is less than equal to 1, or x is greater than -3. So let's go ahead and graph this on the number line so we could see what's going on. Okay, so we're going to have a closed circle at 1, and x is going to be less than 1. So this goes all the way in this direction. We also have an open circle at -3, and x is greater than -3, so it goes in this direction. Okay, because this is a disjunction, meaning it's an or scenario, the answer is all real numbers. The reason it's going to be all real numbers is because it is the union of the individual inequalities, which would be the entire line. Okay, so we went from a conjunction to a disjunction. Now let's look at another example where we go from a disjunction to a conjunction. Okay, so in this scenario we have x is less than -2, or x is greater than 1. Okay, so let's graph that and see what that looks like. So for x is less than or equal to 2, or -2, I'm sorry, we've got an open circle at -2, and we're going to go to the left since it's less than. And then for the other one, we've got x is greater than 1, so we've got an open circle at 1, and it's going to go to the right because it's greater than. Okay, so this is a disjunction. What happens if we make this into a conjunction? So in other words, x is less than -2 and x is greater than 1. So if we were to graph this on a number line, again, it would look exactly like this. Okay, but now the question is this conjunction, does this conjunction have a solution? Okay, the key word here is and. So we need to find any and all values of x that is less than -2 and greater than 1. Okay, since there's no intersection here, the answer is there is no solution. And the reason it's no solution is both criteria have to be satisfied. In other words, x has to be less than 2 and x has to be greater than 1. Okay, so let's take a look at a few more examples. Okay, so we have x needs to be less than or equal to -1 and also greater than or equal to -1. Okay, so to graph this, we're going to do this. And this is -1. So we're going to graph the first one. X is less than -1. X is less than -1. And then the next one, X is greater than or equal to -1. Because this is a conjunction, meaning both criteria have to be satisfied, the only solution is -1. Okay, here's another example. X is less than 0, or X is less than 2. Okay. So let's graph the first one. The first one says less than 0. So open circle over here, and it's going to go to the left. Okay. And then the second one says X is less than 2. So we're going to put an open circle at less than 2. I'm sorry, at 2. And then we're going to go to the left for less than. Okay? Because this is a disjunction or an OR scenario, the final solution would be open circle at 2 and an arrow to the left. Okay? So hopefully this is starting to make sense. Let's take a look at another problem. Let's suppose X is greater than 1 and X is less than -2. Okay, so let's graph this on the number line. We've got -2 and 1. So the first one tells us that we've got X is greater than 1. So open at 1 and go to the right. And then X is less than -2, which means open at -2, and we go to the left for less than. Okay? Because this is a conjunction, meaning we have to find all values of X's that satisfy both of these criteria, there is no solution because nothing satisfies both. So the answer is no solution. Okay? Let's take a look at a few more. Let's suppose we have X is less than 3 and X is greater than 2. Okay? So let's graph this. We have 2 and we have 3. Okay? So the first says X is less than 3. So we got an open circle at 3, and we go to the left. And then we've got an open circle at 2 for X is greater than 2, which goes to the right. Because this is a conjunction, right, because of the word and, the only thing that satisfies it is between here and here. And so our final answer is open circle at 2 and at 3, and we connect those. And that is your answer. And we'll do one more example. X is greater than 1, sorry, -1, or X is less than 0. Okay, so we plot this. It's -1, we've got 0. So first, we've got X is greater than -1, so we're going to put an open circle at -1, and we're going to go to the right since it's greater. And the next one is X is less than 0, so we're going to put an open circle at 0, and it's going to go less than. okay? Because this is a disjunction, and the tip-off here is the word or, okay? It has, all x value has to either satisfy one or the other. And what we'll see is that because all real numbers on the number line satisfies this disjunction, the answer is all real numbers. Okay, so hopefully I went through enough examples for you to understand this, but if you require a review and need to go through this video again, please go back to the beginning and view the video again. Thank you.